Hello everyone. If you want to solve daily problems of GFG and Leetcode, please visit the channel every day. Okay, so today's GFG question is smaller sum. So what we have to do in this question is we are given n, which represents the length of the array, and we are given an error. We are given an array in this question. So we are asked to do is we have to find. Suppose we are at 1. We have to find the sum of elements which are smaller than 1. Okay, here, so here in this case it will be 0 because 1 is the smallest element present in the array, so the sum of the smaller elements will be 0. For 2, we'll see all the smaller elements which are all the elements which are smaller than 2. So only 1 is smaller than 2, the sum will be 1. For 3, we see all the elements which are smaller than 3. So they are 1 plus 2, 3. Okay. So we have to return an array 0, 1, 3. Okay. So in this particular case, what we are doing is we are finding all the elements which are smaller than 4. We did not find any answer. So it will be 0. For this 4 also, we'll check if there are any small elements. Then 4, then it is not the case. So we'll return 0, 0 as our answer vector. Okay, I hope you have understand the question now. Let's move to the approach. So let's focus on the intuition right now. What we are doing is we are taking this array into another array temp. Okay, I'm copying these elements into another array temp. I'll tell you why we are doing this. Okay, I've done that and I'll sort this temp array. Since in this case it is already sorted, I need not to do that. Once I've sorted this, what I'm doing is I've taken a variable sum which I have initialized with the value 0. Okay, now and I have also taken a map. So understand the intuition very well. I'm traversing in my temp array which is sorted. Okay, remember this, our temp array is sorted. I'm at index 0 which is at 1, so I see 1 is not present in my map. So what I'll do is against 1 I'll write the sum. My current sum is 0. Okay, now I include my temp with this 1 into my answer, into my sum. Now I traverse to 2. I see 2 is not present in my map. So I inserted 2 and against 2 the value of so see, map stores key value pairs, huh? So key is 2 and a value will be sum. Right now my sum is 1. Now I'll do 1 plus 2, current sum plus the element. Okay, now I come to 3. I see 3 is not present in my map, so against 3 I've in, inserted sum which is currently 3. So you see, what we were expecting is against 1 we wanted 0 which is here in this case, against 2 we wanted 1 here, and against 3 we wanted 3 which is here. Let's run this case for let's run this intuition for example 2. Let's again take a temp array. We'll traverse in temp array. And my sum will be currently 0. So see, I'm currently pointing at 4. 4 is not present in my map. So against 4, I'll put the sum, current sum. Now I replaced incremented sum by this value. Now I come to this 4. I see this 4 is already present. 4 is present in my map. So I am not including. So my sum of my answer for this particular index will be again 0, which is already present over here. But with that, I am incrementing my sum as well. For example, if instead of this I would have if I have this as well, this is my answer. This is my array. Okay. Now for 5 would be, I see 5 is not present in my answer. So against 5, what will be my value? 8. Okay. Now see, all the values which are smaller than 5 are 4. 2 times 4, which will give us sum of 8. So did you understand why we are using map? We are using map so that if a variable comes more than one time, we do not take it uh, again and again. Okay. So in this case, 4 was coming 2 times. Okay. But its answer still remains the same because we have to take the smaller elements than 4, and we must not include 4. Okay. That's why we are using a map. Why we have taken an extra array? So remember this. We if we would have sorted the given array only, then we would have missed on indexes. Okay. In this case, in these two examples, we are given an array which is already sorted, but this will not be the case with all the examples, right? With all the test cases. We wanted our approach is such that we wanted a sorted array. Okay. But if we would have sorted the array, the initial array which is given to us, then we would miss on the indexes, because in our answer we have to in our answer what we have to do is against 1 all the elements we have to sum and give against 1 what we have to do is we have to sum all the smaller elements than 1 and then answer it and then present it in the same index. That's why we have taken an extra array. Okay. And I hope you have also understand why we are using map. Okay. So here I have taken an extra array which will store our answers. Here I have copied the given array which is array into our temp array. Okay. And I've sorted it. I've sorted the temp array. Next what I've done is I've taken the sum variable as in to store the current running sum. Then I'm traversing through my temp array, and if I do not the element with the index at which the temp array is pointed, the pointer with the value which at which the pointer is pointing to, if it's not present in the map, we'll insert it. Okay. And then we'll include that element into our sum. And at last, whatever value will be our elements would be taking here. whatever key value pair we have here, see, suppose 1 is pointing at 0, so our answer would also be containing against 1 will have 0. Okay, so I have done this and stored our answer in answer vector. Okay, I hope you have understand the intuition behind this code, and thank you so much for viewing this, and I hope you understand it. Thank you so much. Bye bye. We'll meet tomorrow.